Hello students, this is Dr. Asif, working as Associate Professor and Head in the Department of Mathematics in Vijaya Vittala Institute of Technology, which comes in Hennur Bangalore Road, Bangalore. Let us discuss today's topic, partial differentiation. Let us see symmetric function. A function of two or more variables is symmetric if the function remains unchanged when the variables are cyclically rotated. So this is the definition for symmetric function. Let us take one problem on symmetric function and solve. Problems on symmetric functions. You can see here this function u is equal to log of root x square plus y square plus z square is a symmetric function because when we rotate the variables x, y, z cyclically, the function remains the same. That means if we write in the place of x square, y square, and in the place of y square we write z square, and in the place of z square x square, finally the function remains same only. So such a function is called symmetric function. Now here we have to prove this is equal to 1. To prove this, we need to find dou square u by dou x square, dou square u by dou y square, and dou square u by dou z square. The given function is this. By using the property of root, this root can also be written as to the power half. Now we use the property of logarithm to write this power half as a multiplication. By using the property that log a to the power b is b log a. Here u is a symmetric function of x, y, z. Here also you can check when you rotate the variables, still you will get back the same function. Differentiate u partially with respect to x. Keep 1 by 2 as a constant as it is. Here log of this is a function of a function. First we need to differentiate log with respect to this. Then we need to differentiate this again with respect to x partially. Differentiation of log function gives 1 divided by x square plus y square plus z square into dou by dou x of this function we need to do. That means we need to differentiate this partially with respect to x. Differentiation of x square with respect to x will give us 2x. Since we are differentiating partially with respect to x, y square and z square will be treated as constants. So on differentiation these two will take 0. So differentiation of y square is 0 and differentiation of z square is 0. Now here in the next step this 2 and this 2 gets cancelled. What we get is this. So this is our dou u by dou x. Since we want dou square u by dou x square, we need to differentiate this function once again. When we differentiate this dou u by dou x once again with respect to x, we get dou square u by dou x square. In the RHS, you can see we need to apply the quotient rule because numerator is also a function of x and denominator is also a function of x, by which we are differentiating. Our differentiation is with respect to x. Therefore, we need to use the quotient rule to differentiate this. The quotient rule says, first let us rewrite this as this and take in the place of dou u by dou x this here. We have taken. Now we will apply the quotient rule for this. Quotient rule says square of the denominator, that is v square here, denominator as it is, differentiation of numerator, differentiation of x gives 1 minus numerator as it is, we write this x as it is now, then we differentiate denominator. When we differentiate the denominator, we know it is 2x, differentiation of x square is 2x, and differentiation of y square and z square will go to 0 as these are treated as constants. So differentiation of x square has become 2x, differentiation of y square is 0, differentiation of z square is 0. Now further simplification, x into 2x is 2x square here. Yes, we have this. Now x square minus 2x square gives minus x square. I have written y square plus z square as it is, and this gives minus x square on addition with x square. Let us call this as equation number 1. Since our function is symmetric, we no need to find dou square u by dou y square from the beginning. By just looking at dou square u by dou x square, we can write this derivative and the next derivative also. Just rotate cyclically here, rotate the variable cyclically. In the place of y square, the next, when you rotate, y square becomes z square, z square becomes back to x square, and after x square it is y square. So we have rotated the variable cyclically. That is after x, y, after y, z, after z, x. So that is cyclical rotation. In the denominator, when we rotate cyclically, again we get back same thing, x square plus y square plus z square. So the denominator remains the same here, because when you replace x square it becomes y square, which is here. When you replace y square by z square, which is here. When you replace z square by x square, which is here. So again we got the same thing. Similarly, we can write dou square u by dou z square now in the next step. Let us call this as equation number 2. After z square it is x square becomes y square becomes z square, and the denominator again remains the same. Call it as equation number 3. As per our requirement, we need to add all these three equations. Let us add all these three equations now. Adding 1, 2 and 3 we get. That is, we have added all the LHS of these three equations. We have added these LHS parts. Now we will add all the RHS parts. In the RHS we can see the denominators are same. All three denominators from three equations are same. So when we take the LCM, the denominator will be the LCM as this will be the denominator when we add, because it is same in all the three equations. Then in the numerator we write this first here, then we write plus this term, then plus we write this term. We have added all the three equations to get this by taking LCM. Now you can observe here, minus x square plus x square gets cancelled, plus y square minus y square gets cancelled, z square and minus z square gets cancelled. So what remains? X square plus y square plus z square remains in the numerator. This is what remains. You can observe again this gets cancelled. X square plus y square plus z square will get cancelled with this x square plus y square plus z square one time. So one time will remain here. So this is what we get after cancellation, because in the denominator we have square. One term will remain. So as per our requirement, we will cross multiply this to the other side. This was the equation we were searching for in the question. So this completes the problem.